Okay, so in this video we're going to have a quick look at a recap of electrolysis, and then we're going to get into the electrolysis of aqueous solutions. Okay, so first a recap, some key words that we really need to understand because we'll be using them as part of today's video. So electrolysis, key phrase here, this helps us to understand it. So the lysis bit is about breaking down using electricity. So we're going to break down ionic compounds into simpler substances using a direct current. Okay. Next one are cations. Cations are the positive ions. For example, a sodium ion is a cation. Way to remember it, cats. I'm positive, I love them. Then you've got anions. I always write it with big N here, capital N, because this just reminds me they are negative ions. For example, here's a chloride ion as a cation. Redox. I'm going to show you two equations here just to remind you about this. So redox is a combination of reduction and oxidation, and this is all in terms of electrons. So here we've got a cation, Cu2+, copper ion. Because it's 2+, it needs to pick up 2 electrons in order to become copper with no charge. This here is gaining electrons, so this is an example of reduction. If you're thinking how am I getting this, remember oil rig. An oil rig is oxidation is loss, reduction is gain. So this is gaining electrons, therefore it's reduction. Let's have a look at the opposite side of this. Here's a chloride ion, and what we're going to do is get this to turn into chlorine. So we need to lose this electron. So that electron is being lost. So here's a chlorine without the electron. Remember that chlorine is diatomic, so we need 2 of those. Therefore I need 2 ions, and that will release 2 electrons. Because this electron has been lost, this is oxidation, and then you can see we've got reduction and oxidation, so it's a redox reaction. Final little bit to remember here is around the process of electrolysis. When we do this, we use graphite electrodes, and the reason we use graphite is 2 reasons why we use graphite. Graphite is inert. That means it's unreactive, so it's not going to take part in the chemical reaction. And the second reason is that graphite conducts electricity. And if you think back to the work we did on bonding, this diagram here should trigger some memories that graphite contains carbon. Carbon normally likes to bond with 4 bonds. In graphite it bonds with 3. Therefore it's got a delocalized electron which is able to move through the structure, and therefore it conducts electricity. So it's a good material to use for electrodes. So that's the introduction. We're now going to have a look at the electrolysis of aqueous solutions.